In this skill, we're looking at how the strength of an acid is related to the stability of its conjugate base. In this particular question, a scientist wants to compare the acidity of phosphoric acid, H3PO4, and nitrous acid, HNO2. So we're asked which is more acidic. So looking at our table over here, we've got H3PO4 in the first row and HNO2 in the second row. Both of them are weak acids, and we can see that because we have these reversible reaction arrows in our equations. So to figure out which is more acidic or which is the stronger acid, we're going to be looking at the acid dissociation constant. A higher Ka means more acidic or a stronger acid. So looking at our options here, H3PO4 has a Ka of 7.1 times 10 to the power of negative 3. HNO2 has a Ka of 7.2 times 10 to the power of negative 4. So the Ka for H3PO4 is bigger than the Ka for HNO2. So this Ka is bigger, this Ka is smaller. So that means H3PO4 is going to be the more acidic acid. So we can fill in here which is more acidic. It's going to be H3PO4. We know that because it has a higher acid dissociation constant. The next question asks, which conjugate base is more stable? So looking at our equations over here, here are our acids, H3PO4 and HNO2. And then they both lose an H plus to form their conjugate bases, H2PO4 minus and NO2 minus. Those are our conjugate bases. If we have a stronger acid, in other words, an acid which is more acidic, that means we have more of our acid converting into conjugate base. If we have a weaker acid, we have less of our acid converting into conjugate base. And how much is converted into conjugate base depends on the stability of the conjugate base. If we have a more stable conjugate base, that means more of the acid is converted into the conjugate base. And if more acid is converted into conjugate base, we're going to have a greater H plus concentration and a higher acidity. So that means the acid is more acidic. On the other hand, if we have a less stable conjugate base, that means less of the acid is converted into the conjugate base. If less of the acid is converted into the conjugate base, that means we have a smaller concentration of H plus ions produced. In other words, the acid is less acidic. And remember, more acidic means higher Ka value, and less acidic means lower Ka value. So if we know H3PO4 is more acidic, that means that H2PO4 minus must be a more stable conjugate base. So which conjugate base is more stable? It's going to be H2PO4 minus. Let's do one more question of this type. In this question, a scientist is comparing sulfurous acid, H2SO3, and sulfuric acid, H2SO4. we're asked which is more acidic. So looking at our options here, we have H2SO3, which has a Ka of 1.3 times 10 to the negative 2, and we have H2SO4, which has a Ka of 1 times 10 to the power of 3. So H2SO4 has a much bigger Ka value than H2SO3. So this is going to be the stronger acid. In other words, it's more acidic. Then we're asked which is more stable, HSO3 minus or HSO4 minus. So looking at our equations here, we have our two acids, H2SO3 and H2SO4. They each lose an H plus to form HSO3 minus and HSO4 minus. Now we know that H2SO4 is a stronger acid. So this is going to be more acidic. And according to what we learned here, if the acid is more acidic, the reason why is that the conjugate base is more stable. So this conjugate base is more stable. And that's the reason why more of the acid turns into the conjugate base, because that conjugate base is stable. So for H2SO4, it's more acidic, and therefore our conjugate base must be more stable. So HSO4 minus is going to be our more stable conjugate base. So all you have to do in this question is compare your acid dissociation constants to determine which is more acidic. Then to decide which conjugate base is more stable, it's going to be the conjugate base of the more acidic acid. The reason why is that if we have a more stable conjugate base, more of the acid is going to convert into that base, meaning that the acid is more acidic, in other words, more likely to dissociate into its ions.